All right, welcome back. So we've got a applied problem here. We've got 2 points, A and B are 2 miles apart. There's an explosion. Okay. Um, and the explosion is heard 3 seconds before at A, before it was heard at B. Okay. So now the speed of sound is 1,100 feet per second. We're going to show that the location of the explosion is restricted to a hyperbola, and we're going to find that equation. So first, let's draw a picture. Oh, getting tired of saying that. I need a track to say that. Okay. So we're going to put points A and B here and here. A and B are actually the foci of our ellipse, okay, if we think about it, okay? Because if we think about it, let's say our explosion happens, let's say here. What we're really taking is we're taking the distance here. So we're taking this D2 and D1, and we're saying that D2 minus D1 has to equal 3 times 1,100 and, 100 feet, which comes out to be 3,300 feet, which, just for the fun of it, we're going to say is 5/8 of a mile. Not just for the fun of it, that's actually correct, but we're going to use miles, okay? So now we got to come up with what is the equation of the ellipse. So we know that this is, hyperbola. The equation, hyperbola is the set of points where the difference between the distances is equidistant. So this is what we have here. Okay, so let's find the equation. So now let's go ahead and pretend that the explosion happened on the line between A and B. So suppose we have the explosion. Here, let's call this point, I don't know, let's call it X. Okay, so now, if that explosion is there, then I know this is not drawn to scale at all, but that's D1, right? And then this is D2. Okay, so that's D1, that's D2. Okay, let me take a look at my notes here real quick. So I had it there. Now, here's where we're going to go a little bit tricky. I'm going to get tricky on you. Okay, I'm going to make a point here, negative X. And I'm going to say, you know what? This is that same D1, right? Okay, so now, here's where I want you to sort of think here. Okay. All right. D2 minus D1. So from here to here, what's that? That's 2x, isn't it? Okay, D2 minus D1 is actually 2x. Interesting, interesting. Okay, so that tells us that x is 5/16, right? Because D2 minus D1 was 5/8. 5/8 equals 2x, x is 5/16. Oh yeah. Let's rename that A, little a. So let me rename that little a everywhere. It'll go better with our equation anyways, right? Okay, so A is 5/16. Now, what is our focus? Well, remember our C is this distance. So our C here is going to equal 1. So Remember, a squared plus b squared equals c squared. 5 over 16 squared plus b squared equals 1. B squared equals 1 minus 25. 16 squared, I believe, is 196, but let me just check. 256. Okay. 231 over 256 is b squared. Okay, so now what's my equation? X squared over 5 over 16 squared minus y squared over 231 over 256 equals 1. Let me rewrite that as what? 256 times x squared over 25 minus 256 over y squared over 231 equals 1. Okay, either one of those is fine. Okay, so the key point here, the key point to sort of remember is what? This drawing this out and realizing that this d2, okay, minus this d1 has to equal the 2a. Okay, so this equation, that's really the key point to recognize. All right, I'll see you all in the next set of videos.